The B part of 10.3, so B question, that's asking of the next five patients diagnosed with spinal cord injury in Florida, what is the probability that at least one will be female? What is the probability that at least one will be male? So these are the two sub questions within this. So we have to understand, and actually we have to consider. So usually it's pretty simple that total sample space we represent it in terms of S. In this case, will be male or female. And that's just for simplicity of understanding purpose, assuming something for this question, right? So these are the only two possible events. So that's the total sample space. Now let's see that this is the Florida state and we are removing five different people, and what is the probability that at least one of these five will be female? So that is what the first part is asking. So do we have information for probability of female from this question stem? So actually we don't have it directly. We know that 75% are first chosen will be male. That's the probability of selecting a male. Then probability of female, given that these are the only two possible events, we just subtract it from total, right? Because this total constitute one. So if we want this another one, we have to just subtract probability of female. So 1 minus probability of being male or getting a male. So 1 minus 0.75, that's here. That's nothing but 0.25, and that will be probability of getting the first drawn person as female, right? Oops. So once you know this probability of getting first person as female, you just have to apply the rule that, okay, so we want probability of at least one female among this five drawn. So we say that out of the total probability, we want probability of, we want to subtract probability of all five being female. So let me draw sample space specifically for that. So if you are drawing five patients, so there could be probability that all five will be male, 3, 4, and 5, right? Or there could be probability that all five will be female, or there could be probability that first female and then this all four male, two females, three females, four females, and there will be combination of events also based on the sequence, but I'm just going to write it because I just want to highlight the point that if you are interested in probability of at least one as female, so okay, there is one female, there is one female, there is one female, at least, actually two, there is at least one, actually three, at least one, actually four, but in here there is no female, right? So you know that right away this is the only event that will be not there, that will not be event of your interest in this question, in this particular probability, but rest you will be interested in. So that is why, and you know that this total sample space constitute to 1 because that is the total probability. That is why you're going to subtract it from 1, the probability of getting all 5 male. So basically We are subtracting this probability of all five male is m m m m m, right? That's the one we are subtracting, and we know that probability for getting or first patient drawn being male is 0.75. That's given in the question stem right here, 75%. So we are going to apply that. Okay, that's nothing but probability of getting first person as male and probability of getting second person as male and getting third person as male and getting fourth person as male and getting fifth person as male, right? And we know whenever we have this and rule, we just use the probability multiplication, and that's why we are going to multiply probability of first being male. So let me just write it. I just skipped this one step here, but you can write it. Probability of first getting as male times probability of second getting male, third getting male, fourth person getting as male, and fifth person getting as male. And those are same for because we consider them as independent of these are actually independent events. So that's just the multiplication of those five times because we are drawing five patients here. That's why in next step you are just going to just take the fifth power of that number and subtract it from 1, and then you're going to get answer somewhere around this, and that's nothing but the probability of randomly drawn person randomly drawing five patients with at least one female, right? And you're going to do the same procedure for the second part. What is the probability that at least one will be male? So probability of at least one being male is 1 minus probability of all female. Um, that will be 1 minus 0.25 raised to 5 and 0.9.